In this video, I want to talk about one of the different ways that we can change or transform our parabola. And that change that we're going to talk about right now is called the vertical stretch. And just as a quick summary before I get into demonstrating with Desmos, our equation changes by adding the letter a in front. So now our equation is going to be y equals ax squared, where a is just some number. And in summary, what we're going to see is that when a is greater than 1, so 1.1, 1.2, 3, 5, 7, 1,000, whatever, any number bigger than 1, our graph is going to stretch. That means it's going to get taller. If it's between 0 and 1, so like half or a quarter or 0.195 or whatever, it's going to be vertically compressed. And if our a value is negative, then it's going to reflect about the x-axis. So let's take a look at what that looks like. I'm using Desmos to demonstrate this, and I'm going to give this a quick name. I can't do that. Okay. I'll share a link to this graph in Classroom so you can play with this and follow along if you want. Basically, I have my equation here, and I have a slider. So as I drag this, the value of a is going to change. So by default, with our original equation, before we make any changes, a is just equal to 1. This is the graph that we looked at earlier in our previous video, and we just talked about the most basic and simple parabola shape. What happens if I make a bigger? Well, let's take a look. And that's fine. I'm gonna start increasing the value of a. What happens to the graph? It looks like it's getting skinnier, but what's really happening is I'm stretching it. So originally I have a shape that looks like this. And as I change the a value, I'm stretching it upward. So I'm gonna, instead of, we go over this far, we go up this far, maybe to this point, I'm stretching it up. So now these points are up here. So my graph now it's kind of gonna look like this. So it is skinnier, but it's only skinnier because I've stretched the location of those points upward. So this is called a vertical stretch. What happens when my a value is between 0 and 1? Well, let's take a look. So let's change my a value. Notice my graph is getting wider. Why is it getting wider? It's getting wider because we're compressing it. So let's take a look at that as well. So my original graph, let's say it looks something like this. These 2 points, when I'm vertically compressing it, when the a value is between 0 and 1, I'm squishing it. So let's say I move these points down here. Well, what does the graph look like now? Well, it looks wider. Let's do even further vertical compress. Let's make those points even lower. My curve is going to look even wider. And if we continue on, which we could do, so it looks like my graph is getting fatter. But what's really happening as I'm changing the a value, we're changing the vertical components. So vertical stretch, stretched up, vertical compress, got squishier. What happens if we make the a value negative? Let's take a look at our original value of 1, and let's make it a negative 1. It reflected, it flipped. When our a value is negative, it flips over the x-axis, so it's reflected. Once it's reflected, the same pattern follows. So as I make my a value bigger, so -1, -2, -3, -4, -5, it gets skinnier, it looks like it, because it's being stretched. So I can sketch that for you right away as well. So if our a value is negative, we've reflected over the x-axis. And then as we have bigger and bigger negative numbers, my points are further and further into the negative. Oops. It looks skinnier, so it goes on the inside. And same thing if we stretch it further. So this is like, let's say like -4 or -5 or something. Our graph is skinnier because it's reaching up further. Similarly, with between 0 and 1, so like -0.5 or -1/4 or things like that, our graph is still reflected and it looks wider. That's because, once again, so our original graph, when the a is negative, it's flipped. Then we start doing compression. So it's still flipped because it's negative, but our shape looks wider. Similarly, again, if we have an even greater compression, it can look something like that. So changing the A value changes the shape of our graph by stretching it or compressing it vertically. When A is greater than 1, so like A is 3, or let's also take a look at if A was -3. Same shape, just reflected up and down. Let's see if they were both between 0 and 1. So let's see what happens when A is half. Right, it looks wider because it's been vertically compressed. And let's take a look at -half. Same shape, just reflected over the x-axis. So negative causes it to reflect over the x-axis. If the number is bigger than 1, it stretches vertically. And if the number is between 0 and 1, so like half or -half, it's squished. All right, and that's our quick crash course into vertical stretches and compressions of parabolas.